Good morning, everyone. I hope you are all ready to dive into one of the most exciting and impactful areas of artificial intelligence, AI in healthcare. This is Unit 4 of our course, AI for Social Good. We are going to explore from diagnosis, diseases, faster to designing treatments based on your DNA. In this unit, we will focus on genetic based solutions where AI helps decode our DNA to predict and prevent diseases. We will look at real world applications, cutting edge technologies like CRISPR and pharmacogenomics, and also discuss the ethical challenges because with great power comes great responsibility. So, whether you are passionate about tech, curious about biology, or just want to make a difference, this unit is going to show you how AI can truly be a force for social good. Let's get started. Genetics. Genetics plays a huge role in precision medicine. Whole genome sequencing and whole exome sequencing reveal variations in your DNA that affect disease risks and drug response. AI helps match therapies to your genetic profile, making treatment more effective and reducing side effects. For example, if you have a mutation that makes you resistant to a certain drug, AI can suggest alternatives. This isn't guesswork, it's data driven care, and it's changing how we treat everything from cancer to cardiovascular disease. Role of genetics. Now let's focus on one of its powerhouses, genetics. Your genes are like an instruction manual for your body, and they play a huge role in how treatments work for you. That first point tell us identify genetic mutation. First, doctor can identify genetic mutation that are unique to each patient. Think of it as finding a tiny typo in that instruction manual. Some things that typo can lead to illness, and knowing exactly where it is makes all the differences. Second point, match targeted therapies. Once we know the mutation, we can match targeted therapies to that specific genetic profile. It's like using a custom key that fits only your lock, ensuring the treatment directly addresses the problem instead of using a generic approach. Third point, more effective outcomes. With this match, we can achieve more effective treatment outcomes. Patients often respond better and faster because the therapy is designed for their exact condition. Fourth point is reduce side effects. And here's another big win, fewer side effects. When treatment is precisely targeted, we avoid the trial and error of standard medicine, reducing unnecessary reactions. So, this role of genetics is all about making medicine smarter and more personal, finding the error, fixing it with the perfect tool, and keeping patients safer and healthier in the process. Let's get into the basics. DNA is the molecule that carries genetic instructions. Genes are segments of DNA that influence traits and health. Your genome is your complete DNA blueprint. Genetic variations like SNPs can affect how disease develop or how medicines work. Gene expression is how your body turns genetic info into proteins. AI helps analyze these complex interactions to guide treatment. Understanding these concepts is key to unlocking the power of precision medicine. Here's more depth. Mutations or changes in DNA that can lead to disease. Genotyping and sequencing are methods to read and analyze genetic info. Inheritance explains how traits pass from parents to children, like dominant and recessive genes. Pharmacogenomics studies how your genes affect drug response. For example, some people metabolize drugs faster or slower based on their genes. AI helps doctors use this information to personalize treatment and avoid adverse reactions. There are several genetics based solutions. Genetic testing identifies mutations like BRCA1, BRCA2 for breast cancer risk. Newborn screening for metabolic disorders. Pharmacogenomics. It ensures the right drug at the right dose. For example, CYP2 C19 gene affects drug effectiveness. Third one, targeted therapy uses drug like imatinib for patients with PCR-ABL gene in leukemia for specific mutations in leukemia. Next one is gene therapy. It inserts or corrects defective genes. Like in spinal muscular atrophy, gene editing, especially CRISPR-Cas9, can precisely fix faulty DNA. And predictive healthcare uses genetic profiling to forecast future risks and guide lifestyle changes. Gene editing is one of the most exciting areas. CRISPR-Cas9 allows scientists to cut and fix DNA with incredible precision. It's being used to treat sickle cell anemia, thalassemia, and hemophilia. Predictive healthcare uses genetic data to identify risks early, so people can make changes before disease develops. AI helps analyze this data and suggest interventions. It's proactive, not reactive, and it's info transformation how we think about health. So applications are everywhere. In cancer treatment, AI helps design personalized drugs based on genetic mutations. For rare genetic diseases, gene therapy and editing offer new hope. In drug development, AI uses genetic biomarkers to create more effective medications. Prenatal and newborn screening can detect disorders early, allowing for timely interventions. These aren't just ideas, they are being used in hospitals and labs around the world right now. The benefits of genetics are huge. Personalized treatment, better outcomes, and fewer side effects. Early detection helps catch diseases before they become serious. AI improves patient safety by predicting adverse reactions. And overall healthcare becomes more efficient and effective. Better patient safety. It's not just about curing disease, it's about optimizing health, and that's a win for everyone. Now, but there are some challenges in genetic solutions can be expensive. limiting access. There are ethical concerns like who owns your DNA data and how it's used. In developing countries, awareness and infrastructures are very limited. AI system can also be biased if trained on incomplete data. So while the technology is powerful, we need to ensure it's fair, ethical and accessible to all. Thanks for listening. AI in healthcare is changing lives and it's just getting started. Genetic based solutions are making treatment more personal, more predictive, and more powerful. So let's keep listening, keep questioning, and maybe one day be part of the innovation ourselves. Thank you.